Yeah, extra credit for home run. Do they give you the ball if you hit a home run? Yeah. Becomes your property now? I accidentally started the video.
Well, it's okay.
Jesse, get out of here.
I don't know.
Probably not.
I don't think my parents would ever see me.
They should.
They should.
Yeah, my sister.
My dad is more of a that bad, huh, J-Hall? Bird law versus tribal law and water law.
Really?
What
about bird law?
Bird law?
Bird law.
How about tree law?
To tribal law, then yes.
How about tree law? Here's the thing.
Again, if it relates to tribal law, then yes.
There's this TV show where the guy keeps trying to say that he's like, my expertise really is in bird law. Classic.
Probably
Okay.
classic.
Okay, more stuff. What Ave?
Life is pain. Today has been a bad day. Oh. Could you single each one just go through and cross out and write 5.3?
Blankenship, did you bring your good luck stuff?
What? My good luck duck hit me a home run.
I know what you're bringing for quiz day.
I did. It's over the ball or
Okay,
the duck.
good. Good. I heard it brought you luck.
Yes.
You guys pass.
I do have the duck.
Pass
All
these
right,
back.
good
Great.
deal.
I don't like
So guys, like I said, you turn your problem set on Monday.
Well, I
Make
wasn't
sure it's
here,
done.
so how am I?
Is this the last packet?
No.
Is there one more after this?
Yes.
Oh.
There's only one more packet after this? Holy cow, we're that close.
Thank God.
So what are we doing this class after the?
Probably nothing.
We're gonna do one more unit on polar calculus involving polar coordinates, non-Cartesian coordinates.
Polarity?
Oh. This would have been nice to know.
What?
That. Well, actually, a lot of this would have been nice to know like 3 weeks ago when I did the math problem. But it's okay.
Okay, so
I'll forgive you.
did everyone get one?
Yeah.
You got two extra?
Yeah, well,
Yeah.
a wrap and then you wanted.
Rat.
Ah,
rat.
You can't use that terminology.
Okay. So every integral is just there's really not a whole lot of new information here. Full disclosure. It's pretty much what we've already covered, except now we have a couple more derivatives that we could anti-derivative. So I'll give you a really simple example. It's like the simplest example is the derivative of the sine function is the cosine function, right?
Mhm.
So what fact do you think goes hand in hand with that fact?
Cosine is,
There you go. And don't forget all the basics of that at a constant, right? And then there's a little bit, okay, what about the whole chain rule thing? Okay, that's fine. What that would mean is, one more simple example would be like the derivative of the sine of x cubed would be 3x squared times the cosine of x cubed. Okay, so that's another fairly basic result. So that therefore, if I had an integral, so remember this idea, sine of u would turn into u prime cosine of u. So the reverse of that is I need the u prime to be there in my integral, and I need him to disappear. So for example, suppose you had, this is a fairly standard looking one. Suppose you had this integral. Notice I conspicuously left some room there. If you were dealing with this, you'd say, oh, well, I've almost got a u prime cosine of u. I'm very close to having it. What I would have to do is multiply the inside by 3 and multiply the outside by 1/3 in order to balance it out. And then my answer would be to this, my answer would be 1/3 times the sine of x cubed plus a constant. Do we understand the main idea? So this is not anything new. This is it's the chain rule from before. Right? Does that make sense? Yes, the fact that now we're doing it with sines and cosines is different, but it's still the exact same principle that we did for a long time with all the other integrals. So let's do. Thanks, Jesse.
Well, I figured I'd wait until the
Yeah.
explanation was over.
Thank you.
Yeah.
So what's the integral? What's the integral of e to the 3x? Let's see. E to the 3x. What's the integral of just a plain old e to the x? E to the x plus c. So this is awfully close to being u prime e to the u, right? Because we know that the integral of u prime e to the u is going to give us e to the u. Do we understand this idea?
Mm-hmm.
Because the derivative of this is this. So the antiderivative of this is this. Okay? So who do I need to live there? 3. Which means I need to put a 1/3 out here, because if I don't put the 1/3, I just willy-nilly made it 3 times bigger. That's not good.
Willy-nilly.
So my answer is 1/3 e to the 3x. Now on these really simple ones, you can test your answer in 5 seconds, right? You can go, oh, okay, well, what's the derivative of this? Oh, the derivative of this would be e to the 3x, which is what was in the integral to begin with. Okay?
Okay.
Make sense? Okay. So let's do the next one. How about the integral of 2 to the x? Let's think about this. So, and when you first start doing these, a lot of people like to just, they'll jot down something they know first, just to help keep things all together. They'd be like, well, I know that the derivative of 2 to the x is the natural log of 2 times 2 to the x. So therefore, if I want to reverse the process, what number do I need to live there for this to work out?
The natural log of 2.
Natural log of 2. So here, I'll use red. So what I'm going to do is going to multiply the inside by the natural log of 2, which means I need to multiply the outside by the reciprocal of the natural log of 2 to keep things balanced. And so my answer is have we come to terms with Mr. U prime, or with this guy disappearing, the kind of idea? Like in this one, this is my U prime, and he exists to disappear. That is his function in the circle of life.
Or just.
Huh?
Or just.
Right, when taking the derivative, he appears. Right? He appears. This isn't really a U prime. He appears when differentiating. He disappears when integrating. Okay. By the way, this is a fairly fundamental result. It's actually on your sheet. So when you differentiate, say 2 to the x, you introduce a log of 2 term. When you integrate 2 to the x, you introduce a 1 over log 2 term. Okay. Let's do a few more. You Think about C. How does C look for us?
Do integral of 5e.
Yeah, you got e to the 5x plus 3. That 10 that lives here, you're like, I think I'm going to take that 10 and split them up into a 5 times 2. See what I'm doing there? Make sense? Questions? Okay. So now I've got u prime e to the u, which is going to turn into e to the u for me. But there's still this 2 out here. So I get 2 times e to the u plus a constant. Once again, it's very easy to check my answer. I can go, well, what if I differentiated this? Well, I would get, I think I started. Feely report? Make sense? Okay. Why don't you,
Can you do E?
just split it up.
Yeah, just.
So the trick to E is you're like, well, yeah, this one's looking weird, but if you rewrite E, if you still suck, we can go over the rest, but I think if you split it up into, well, it might be 2 steps. The first thing is to split it up into this, right? That's a common theme when you're integrating is you have a fraction with a sum in it. Is if the sum's in the numerator, you can, a lot of the time splitting it up is the way to go. If the sum's in the denominator, that is often a different story. You can't split that up. So, who dat?
It's e to the
The
negative
negative x,
x. That's 1.
that's 1. And don't forget your basics. The integral of a function plus a function is just, you can just integrate them separately. So what do you think you're going to get when you integrate e to the negative x?
Negative.
Negative e to the negative x. And of course the integral of 1. I do try the rest of these. Give h a shot. We'll go over h, but it's if you can figure it out, that would be neato burrito.
Right.
You will see I gave you the next page, I think the reciprocal of this guy, which is an interesting one to think about. Anyway, yeah, take a couple minutes. Make sure you know how to do those. Discuss them. We're gonna do the attendance. Attendance is the best. Okay. Everyone here? Oh no, Caleb. No, Caleb.
Yeah.
J-Ho.
What up? Savage. Just put the plus C on there.
Oh yeah, let's see, thank you. I keep
Nice
forgetting.
job.
I started doing that and then I forgot for like the last 4 points. Just gotta roll call on him, J-Ho.
Yeah, just roll call. That's all you gotta do.
Literally, coal. See. Never mind. Doesn't matter. Because coal starts with C. Doesn't it? Yes. C-O-A-L. For a second, I really doubted if it started.
That makes me wonder if there's a Coles theorem.
Mhm. I bet it's like KOHL though.
Well, there is. It's kind of obscure stuff. Looks like.
What is it?
I don't know. Is that right?
Unfortunately, that's pretty high level stuff there. Because there's a Rolle's theorem. So you get a Rolle's theorem and then a Cole's theorem.
Oh my goodness. Oh my goodness.
How do
you start this?
Yeah, how do you do a?
So rewrite it as, so the first thing you gotta do is direct your attention to the root x that's in the e. So you go, oh, I got e to the root x. Then say, well, that's a big clue that that dude there is like your u. So then the question is, where's my u prime showing up? Right, because I'm looking for the form u prime e to the u. Sorry. So this like shapes your thinky winkies when you do these kind of things. Is you identify the u and you say, well, how am I going to get my u prime in here? So then you might say, well, what's u prime? This has to be the u. What's the derivative of just ignore everything else? What's the derivative of that? 1 over 2 root x, right? So then you go, oh, wait a second. My integrand is written as a fraction, but I could just as easily write that like this, right? So far I haven't changed anything. This is identical to the original question, right? Just missing one little thing. But do you guys, does this make sense so far? This is going to come up a lot. This is a common theme. It's manipulating the integrand to squish it into a form of u prime times f of u. So I'd be like, oh, he's so close to being a u prime. I just need to put a 2 there.
What, by 1/2 and put a 2 on the outside?
Oh, because it's a fraction.
I basically just divided this by 2. I divided this by 2, so I need to double the outside. Do we understand this? So therefore, I have my u prime e to the u, and so this 2 just gets to tag along, and you get this really nice answer. Pretty.
J-Hope.
What
For
up?
a second I was like, what? That seems so like, this one I was like, this doesn't seem like anything, but then I was like, aha, thinky winky. J-Hope, I always forget.
Hashtag don't forget. What's up?
Yeah. Oh, and I wish Julia were here. We found, we walked at River's Edge for a while, and we found this Easter egg. And in the Easter egg, there was chocolate, but there was also a paper that said, "Don't forget, Jesus didn't stay in the grave; he rose, and he's still alive in the world today."
Jesse. Aiden. Okay. So G, you got it. So your U. Did you get an answer or are you stuck?
No, I got an answer. I just want to.
Does it have a 1/3 in it? Well, you see where that 1/3 is going to come from?
Yep.
So, Mr. Hall, it's going to be like x cubed, 1/3 x cubed times e to the x.
What I'm saying, no. So you see how that one, so for G, you guys are talking about G, right?
Yep.
What's the U?
X to u. X cubed plus 1. So if you are having any trouble, this is my recommendation.
So you got to think really systematically if you are, okay? So if you're having trouble with this, look at that and go, okay. Start with the simple thing, which is what's the U? The U is that. It's got to be. If that's not U, then this is we're out in left field doing some really, really complicated question that's we haven't covered. So that's not going to ever be the case. So U is that. Okay, think of the pattern. We've always been, every time we have a U, we're interested in knowing what's U prime. And then you have to have, maybe on the side here, the big idea, this is the big idea, is that when you're integrating, if you have U prime e to the U, that's going to give you e to the U. Yeah. This is the chain rule. Okay? So then you say, okay, do I have a U prime here? No, but I'm very close to having a U prime there.
You have to add a little.
Let's just put a 3. Now this guy is U prime.
But now you have to throw a third up front.
I got to put a 1/3 out front. So now, really close. So everything except for the 1/3 now is an exact replica of this, right?
Yeah.
I got U prime, e to the U. Bailey, are you getting any of this? So you got U prime, e to the U, and then now, so the answer is going to be e to the U plus c, but don't forget, there's still that 1/3 multiplying everything. And so, now if you're thinking, well, doesn't the 1/3 also multiply the c? Well, so, yes and no. Like c can just represent any number, so 1/3 of that number is still just some arbitrary number that you might pick later. Okay? Understand this? So where did the x squared go? He disappeared. Right? Just like,
That's the only confusing part to me.
here's the thing. So I don't know, there's some food for thought. Why do people, something about maybe about the human mind, I don't know why we think appearing in this context. Students almost never have any problem with the chain rule. Like if you just take the derivative of this, a 3x squared pops into existence, right?
Mm-hmm.
And it's very rare for someone to say, this doesn't feel right. But when we do the opposite, when U prime disappears in the opposite process, it's very, very, it's a common point of confusion. So I don't know, it's interesting. So I don't know the answer to why it goes. Okay, let's go to the next page. Yes.
Just a question on F. So would I change that 1 to also to a 4 and then throw 1/4 out there, or do I?
No. For this one, you want to think about splitting that up. So if you're going to be really thorough with your work, you might say that integral is equivalent to the integral of 1 dx plus the integral of this dx. You really are integrating them separately. So this guy's not going to be affected by, this guy, you're right, is going to need a 4 and a 1/4, right? That doesn't really affect this guy. So for this one, you should get,
So that's not good.
what?
And I was like, why am I so like this? It's because I don't drink coffee, but in Spanish, we were having Cuban food, and she's like, we have to have Cuban coffee, and now I'm dying. I was like, why am I so weird? Oh my God. Like, my brain is like, does that make any sense?
I think I understand what you're talking
Okay.
about. All right. So, next, if you look at the first question on the next page, integral of 4 over x. You you might kind of go into your memory banks there and go, well, do I know what function out there has a derivative, like the derivative of what would give me a 1 over x type function? What kind of function? It's the natural log function. right? Need some water?
I have some.
It's a vegan.
I don't think we're.
So-
Is it only the natural log function that has a derivative of 1 over x?
I mean,
Good question.
yes and no. Yeah.
I would say yes.
Yeah.
Yeah, because I think that gets into like uniqueness. So yeah, does every well, let me clarify. You can add any number onto the function, of course. Log of x plus 2 and log of x plus 3. But yeah, I don't believe. I'm gonna tentatively say. No, I'm gonna upgrade that to confident. Pretty confident. Yeah, no other function can have the same. It would have to be a function that was equivalent to this function. Right? If every single slope point was identical, and again, yeah, you can add a constant and still achieve that, but no other shape could have that same relationship. Okay, so the answer to this one is, now if it's not clear yet, you might go, well, that 4 is just chilling. I could pull the 4 out of the integral. Like that, right? Same thing. So therefore, this would be 4 times the natural log of x. That's constant. And then there's there's a small little thing. It's not super critical. You might recall the fact that, the natural log function looks like this. And if I want him to have if I want this relationship to hold for all x values, one thing I could do is actually turn it into this. Mirror symmetry, so negative slopes, negative y values. Positive slopes, positive y values. So that's one way to do it. So you just letting you know if you may encounter that as well.
Should we put that on?
Yeah, just put it. We're not going to get super duper hung up on that, but it is a thing. It's out there.
On the AP test, will they be like,
That's a good question.
that was an awful noise. It wasn't even a good noise.
Well, on a multiple choice, I would be pretty shocked to see like this is answer A and answer B just doesn't have the absolute value. But if it's a free response, that would be a weird free response question. Just what's the integral? I mean, that would be an incredibly easy question. We would never see that. But I want to say that you shouldn't be penalized for that. But.
Okay. What?
Okay, let's look at B. All right, B.
B?
B. Now for B, what you got to realize is we talked about this. This is a big thing, right?
Make them separate, right?
Huh?
Make them separate, right?
Well, you can't separate that fraction, bro. Right. A plus B over C is the same as A over C plus B over C, but A over B plus C is not generally the same as, I mean, I don't know what you would try to do here, but, well, a lot of, this is one of the various freshman type mistakes, so.
Oh, yeah, incorrect.
They call this like the freshman's, this is the big one, I can't remember, it's the freshman's dream or something. That's like one of the biggest. I mean like undergraduate freshmen is what they refer to. It's like the graduate students grading the work. I think I see that so much, but this is definitely another one. You can't do that, right? Cool beans? There's a whole bunch of really simple examples of why that doesn't work. Like for example, 1 over 2 plus 3, that's a fifth, right? Is a fifth the same as a half plus a third? No, that's insane. Doesn't make any sense. Right? what I'm saying is this comes up all the time, but like if you think about it for a few seconds, it's like, oh, that doesn't even come close to making sense. Right? Whereas the a plus b squared does have a little, in terms of the size of the numbers, it does make a little better.
If we had multiplied it, it kind of would have worked. Oh, no, it wouldn't.
With what?
Right, this for-
No, it is true that 1 over 2 times 3 is equivalent to 1 over 2 times 1 over 3. That is
No,
correct.
that's not-
That is correct. Okay, so the derivative of log of u is u prime over u. That's a really, really bigly result in quack mumbles. Why is that so bigly on integrals? Well, what that tells you is anytime you see an integral and it has the form of u prime over u, you're going to get a natural log of the bottom.
Thanky winky.
Winky winky. So look at B. B says, what's the integral of? So that's actually one of the bigger ideas of like learning how to integrate things is being on the lookout for this form. This is very common. Okay. So when you see a fraction that can't be split up or manipulated, your eyeballs should always go to the bottom and say, that's my u. Do I have a u prime on top? He's already there for us.
Yay.
Wow, thank you for being there for me. So the answer is,
Natural log of 1 plus u.
yep. Okay.
Just want friends to be back on Netflix. Oh. Hey, I finally rewatched everything.
What up?
Why don't we put the absolute value on that?
You could. This is already always positive anyway, though, so it's samey wamesies. Because so like this and this are, those are the same thing. Just so happens that, yeah, because this guy can never be negative anyway. Here's some fun food for thought. Fill in the blank. For large x values, not even large, just for like any x value that's bigger than, I don't know, 3 or 4, what would this be really close to? What function would it be approximately equal to? Who said that? Mr. Trenton. Good job. Yeah. Because what if the 1 wasn't there?
Yeah, okay.
Log of e to the x is x. So you throw a plus 1 in, well, once x is kind of big, like e to the 8th power plus 1 is pretty much the same number as e to the 8th power. They're very close. So this would be, I don't know, it's kind of interesting. This would roughly be equal to y equals x. Look at C. Look at it. Behold it. Behold, Trenton. Do you see? Okay, look at C. Where do your eyeballs go? The bottom. What's the u? X squared plus x. So Jesse, you should love this because there's so many opportunities to say make it so. Like Jean-Luc.
God.
So for C, you should take your eyeballs and go, well, wouldn't it be nice if I see a U on bottom? U.
Brady's River.
Yeah, so what am I looking for? What would I like to live up top? Life would be easy if the top was 2x plus 1. Is the top 2x plus 1? Almost though.
Yeah, you just gotta take the 3 out.
Yeah, the top. So since we know what we're looking for, so it's not obvious at the start that the top needs to be written like this. right? But once you have your attention focused on getting this, like once you know that's the goal, it'll pop out to you. And then you say, well, where can this 3 live?
Outside.
The 3 can live outside, right? He's just a multiplier.
So,
So do I have now, let me rewrite this. So now I have, this top is a u prime now. I have 3 times the integral of, now I have a u prime over u. So the 3 is chilling. You got pulled out. What is this going to turn into?
9 of x
squared
plus x
yes,
plus c.
yes.
Cool beans?
Oh,
And so like this time, like last time Aiden was like, what about the absolute values? Yeah, it might be a good idea to put them on because this thing certainly could be negative. But again, it's not like the big concern. It would be important if you were doing a definite integral, like, oh, what's the integral of this from -1 to 0 or something like that. Then you'd be like, oh, I don't know. Think about what the heck I'm doing. Feely report, Trenton? Feelies?
I like that. Yeah.
So what if you just manipulated before looking at u or u prime and just put the 1/3 on the bottom? 'Cause then
Where here?
Yeah, if you just multiply the bottom by 1/3 and then put 3 on the outside.
That's a good way to think about it.
Yeah,
Yeah.
never mind, it's the same.
Yeah.
I messed
There's different ways you can kind of, conceptualize what's going on here. I tend to think about it as just pulling the multiplier out, but you could also say, I'm going to multiply the inside by 1/3 and the outside by 3. And then you get the same outcome. Okay. So,
Why did you suddenly become like an Instapot?
I was the no tyranny snake, actually. I was the don't step on me.
Oh boy.
Of course.
I should have known. The tyranny snake.
He doesn't like tyranny.
No.
What's that?
What's happening?
It's a new dance? Yes.
Can we do 8?
Yeah. Yeah, H is there just to throw you off there. Can H possibly be a u prime over u? Think about that. Can it be that? If it was going to be that, then u is e to the x squared. But then how would I get the other thing I need? So then I got to shift my thinking and go, well, okay, maybe it's just, yeah, well, let's see. I've got, can I rewrite it as x times e to the, what I do?
Negative.
Like that? Is that, what you're going to find when you do integrals is there's sometimes an element of guess and check. Like you like, I think it's a good way to start this problem is to say, I'm looking for a u prime over u. And then after a few moments, you'll be like, I don't see how I'm going to get that form to arise. So then you shift your thinking and go, okay, well, maybe I can rearrange it. And then now do you see that has the potential to be, it's awfully close now to being a u prime e to the u question, integral. So who do I want? What do I want to add to him? We'll multiply to him. -2. I don't want to unbalance things, so I need to then put a -1/2 on the outside. But now this guy, he's got the u prime, and there's the e to the u. So this is going to become, don't forget the dude that lives out there, -1/2 times e to the. And then if you like, you can put it back into the form of the original where that e to the x squared was chilling on bottom. Not like that's nothing, it's not that necessary.
Can you do D really quick?
D,
Mm-hmm.
you got it, come on, you got U, right, at the bottom. What's your U here?
4 minus x squared.
Okay, so what's U prime?
4x minus 2x.
No, don't mix up your,
Well, the x, I guess, is the u.
so if we say that, so net form, if U is 4 minus x squared, then U prime must be
Oh.
negative 2x.
Mm.
Which means, so it sounds like you were mixing up your integrals and derivatives. So when you identify the U, and then you try to identify the U prime that goes with that, you're taking a derivative. And then you look at the top and you go, well, that top is awfully close to being this, right?
Mhm.
All right, guys, do a couple more for a minute. I want to end with a couple from number 3, which tend to be a little bit trickier. Just a little bit. Just a little bit.
That's fair.
You okay, Kate? Poor Kate. She gonna be okay? Yes? No? Maybe?
I don't know if I'm gonna be okay.
Yes, you are, Jesse. You're fine.
Well, I don't feel great.
Jesse, no! Want some chocolate?
No, that would make it worse if I.
Make it worse?
Yeah, my brain, I'm just like, everything in me is kind of like, you know? It doesn't make any sense. I am also now very nauseous. I don't know why I drank that. But I was like, well, you know, it's the once in a long lifetime bad idea.
I'll do it.
Especially because it's a dumb idea. Not fun. No, I get heart palpitations from
Oh,
this.
that's.
Yeah, so it's not fun. Would not recommend. So I don't usually drink caffeine or a lot of it. Also, my brain's already wild, so now it's moving so fast.
This is what I want to end on. Just a couple from this area.
Oh,
Although actually, we'll also do like maybe like E. Yeah, she got it.
Yeah, do E and G.
So from number 3, I'm going to go A, B, just because they're very similar looking,
He
right?
doesn't exist, does it?
They're very close to each other. It's the same technique on both. And then this one, I think, has a really weird answer. This one's a really weird answer. Interesting answer. And then I want to talk about E. E is very tricky. Very, very tricky. But the technique on E is surprisingly simple once you see it. So look at this guy. So, I'm certainly not, if that's my U, then U prime is just 1. So is that obvious enough that that's not working? Okay. So, okay, then that's probably not going to be the path, right? So let's try maybe rewriting it as a product. Let's see what it looks like that. I could write this as 1 over x times the natural log of x. Do we understand that?
Mhm.
Then we go, wait a second. Who's the u then? This guy. And And u prime is just right there. He's already there for us. So what's the integral of u prime times u?
It's just you. Oh, no, it's not. Sorry.
The same?
Is it u plus c? Wait, what are we saying?
What's the integral of x?
1. Come on.
Is it one
Gotcha.
over?
Oh,
I don't know,
x.
Jay.
One half
Oh, just say it.
1/2 x squared plus a constant. Come on, please. Get a little bit of review here. So the integral, it's okay, the derivative of x squared is 2x, for example. The integral of x would be, you remember you raise the exponent
Yeah.
by 1, and you divide by 2
Okay.
for the constant.
Okay.
So, therefore, the integral of u prime times u to the first power would be u to the second power divided by 2. You feel okay about that? Power rule? It's power rule. So, u prime times u is going to give us 1/2 times u to the second power plus a constant. And of course, the u is log of x. It's kind of weird, right? You can check your answer again pretty easily. What's the derivative of u squared? Go 2. Oh, the 2 would knock out the 1/2. And I'd have log of x times u prime, which is 1 over x, and I would get back to where I started, right? Okay. This one, we're not gonna have time to do e, that's fine. Just if you want to try e and f, go for it, but don't rack your brain. We haven't covered that yet. So anyway, this guy. I'll give you a hint. This one is of the form u prime over u. So now that I've told you that, a little bit of a puzzle. So I'm telling you, it is u prime over u. So what's u then? It's going to require rewriting it, yes, but
Is it 1 over x?
1 over x is the u prime. Very good, yes. So if this is going to be a u prime over u, then this had better be the u. This had better be the u prime. Now, is this equivalent to this? Are those the same thing? Laura, you guys getting this? Yeah. Okay, so you've got u prime over u now. So what is u prime? So u prime over u becomes what? Is going to turn into natural log of u, right? Plus the constant. I know this is very sloppy notation, but hopefully you know what I mean, right? So this, what's the answer going to be then? Natural log of the natural log of x plus constant. Kind of weird, right?
Yeah,
Yeah, but
it's fine. Okay.